Hello and welcome to our guest speaker, Deb Gajic. She is going to explain all you need to know about research methods in psychology. This episode, Deb is giving us information about experiments in psychological research. Asking the questions is our host, Blakemore.
Good morning again. What are we going to be looking at today?
Good morning, Dorothy. We're going to be looking at the experimental method today.
Oh, great. So what is the experimental method?
Well, the experimental method really is the cornerstone of science and of psychology, and it's all about establishing cause and effect. So a researcher sets up a situation and then records what happens. As I said, it's central to the concept of psychology as a science, which I know students often struggle with. I have a little acronym that helps remember the main features of science, and that's FORCE, FORCE. So experiments tend to be falsifiable, objective, replicable. They establish cause, and of course they're controlled, so two C's really, and they provide empirical evidence.
Great. So what's an independent variable?
All experiments have to have an independent and a dependent variable, sometimes more than one actually, depending on how complicated you're getting. So the independent variable is the one the researcher manipulates or changes. It's basically the cause, and that's the independent variable, the one the researcher changes or manipulates in some way.
Okay, so what's the dependent variable?
The dependent variable is the effect. And I always remembered this when I started studying psychology because I used to mix the two up. The dependent variable depends on what you've done to the independent variable, and that helped me.
Great.
So, as I said, it's the effect. What we really need to make sure we do, though, independent and dependent variables must be fully operationalized. And what we mean by that is that they're stated in a clear, measurable form. And that's because that helps with replicability, which as we remember we said before, is one of the cornerstones of science.
So how do we operationalize variables in an experiment, in an experimental hypothesis?
Well, the hypothesis is a prediction of what we expect to happen. So we've got to be really clear about what our IV is and what our DV is. So, for example, if I said time of day will affect memory, that would be a really rubbish hypothesis because it's too vague. What do I mean by time of day? What do I mean by memory? They're too broad a concept to have any meaning in a hypothesis. So, my IV would be time of day, but I'd have to specify a time like 9 o'clock in the morning and 4 o'clock in the afternoon, being my two conditions. I've got to be clear. Memory, how do we measure memory? Well, we can't really measure memory, so we have to go back on the old favourite of how many words a participant will remember from a list of 20 common words, for example. So when I then put those into a hypothesis, I'd be saying there'll be a significant difference in recall of a list of 20 common words between participants who complete the task in the morning at 9 o'clock and participants who complete the task in the afternoon at 4 p.m.
So what does it mean then when we say experiments are all about control?
Experiments are all about controlling our variables, and obviously we start with the IV and the DV. But there are other factors that could affect the outcome, that could influence the DV, that are outside of the IV. And these come in two main types. So we've got situational variables like time of day, temperature in the room, noise levels. And we've got participant variables, so age, gender, etc. So when researchers design an experiment, what they need to do is try and control those variables as much as possible. One of the main ways we control situational variables is through standardization. So making sure everything's exactly the same for every participant. So if there is an effect, it's affected everyone in the same way. Individual differences are a little bit more complicated to control, and we try and control those through experimental design, which I'll talk about a bit later on.
Okay, so what are the main types of experiments?
I suppose when people think about experiments, what they tend to think of is laboratory experiments. We take ourselves back into a chemistry lab, don't we? We're looking at test tubes and pouring one chemical onto another chemical and seeing what would happen. In psychology, when we're talking about a lab experiment, we're talking about controlled environment. So we're controlling our situational variables so that we can be really sure that it's the IV having effect on the DV. The issue with that is, though, by its very nature, when we set that up, it's really artificial, it's not real life. So we say it lacks ecological or external validity. Just because something happens in the lab or in a controlled environment doesn't mean that that would happen in exactly the same way in the real world. So one of the things we try and do to make our experiments more realistic is carry out field experiments. Now, these are not in a meadow full of cows. They are just in the real world. So we've got a much more natural environment, so it's got higher ecological validity. But the problem is, of course, in the real world, it's much harder to control other variables. So a good example of a field experiment would be Hilly Arvin's Subway Samaritan experiment when they looked at helping behaviour on subway trains. Well, you can imagine there's a whole host of things that could go wrong there, isn't there? Things that you can't control, other passengers, the train breaking down. There's just everything you can imagine.
So what's the difference between a quasi and a natural experiment?
This is one that always trips students up, usually because we don't see that many of them really. So a natural experiment, the IV is not directly manipulated by the researcher. There is an IV, but it already exists. And it's usually an event which has already happened. And a good example of this is Charlton's study from 2000, where he carried out a natural experiment to see what the effects of the introduction of TV would be on children's antisocial behaviour in St Helena, which is a remote island in the middle of the Atlantic. Now, obviously, Charlton didn't have any control over the IV, which was the introduction of TV. It was going to happen. He just took advantage of an event that was going to happen. So he measured children's antisocial behaviour before TV came to the island, and then a few months later when TV was there. The major difference between a natural and a quasi, whichever way you want to say it, is it's similar because the IV is still not manipulated by the researcher, but in this case, the IV is a participant variable. So things like age or gender. So an example here would be boys will be more likely to imitate an aggressive role model than females, for example.
What's the different types of experimental design?
Experimental designs are all about how we allocate our participants to our conditions. Typically, we'll have a control condition, which is our baseline, and an experimental condition where we've manipulated the IV. So we need to decide how we're going to put our participants into those two conditions. So the easiest one, independent measures design, independent because the two conditions are independent of each other. We just get our participants, split them in half. Half of our participants do condition A, half do condition B. If we've got a quasi experiment where the IV's age or gender is the only possible design you can use. Obviously, the major issue for this is participant variables. We're never sure if the effect on our DV is due to our manipulation of the IV or that just it was different people in the two conditions. What it does control for, though, are practice and order effects. Sometimes it's not possible to have participants doing both conditions of the experiment because once they've done one, they'd know what to expect for the second and it wouldn't work. Or practice effects, you can either get better the second time or you can get worse because you're tired. So it does have drawbacks, but sometimes, it's the appropriate sort of design.
Okay, so what's a repeated measures design?
A repeated measures design is when participants do both condition A and condition B. And obviously, this controls for participant variables because it's the same people in each condition. The issue we have, though, is practice and order effects because they're doing both conditions. Now, one of the ways we can try and control for this is by counterbalancing or randomization of the presentation of tasks. So we might flip a coin. Heads, you do A followed by B. Tails, you do B followed by A. Or we might do the other technique. First participant does A followed by B. The next one does B followed by A, etc. We still have an issue, though, of demand characteristics because participants are doing both conditions. They're more likely to guess the aim and maybe change their behaviour. And then the final experimental design is matched pairs. Now, you don't see this used very often in psychology. Probably the only example you'll come across is Bandora's study, where he had the nursery workers rate the children on levels of aggression before he started, and then he matched them. So he'd got, say, if one kid had a 3, in the other condition, you'd have another kid with a 3 because it was out of 5 and so on. So they're trying to control for individual differences to a certain extent. And it also controls for practice and order effects because they're only doing one of the conditions. Now, most people say, well, that sounds like perfect compromise. Why isn't it used more often? And it's simply about convenience. It's actually really, really difficult to accurately match participants. Even if you had identical twins, the older they get, the more different they get. So it's really time consuming. You need loads of participants to try and find out who matches who. So that's why it's not used that often, really.
Okay, so that's really good. Has that covered everything for experiments?
I think it has, yeah. And as always, look at past exam papers. There's always lots of questions on experiments. Make sure you're really clear on types of experiments, experimental design, and how you operationalize IVs and DBs.
Excellent. Thanks very much, Deb.
You're welcome.
Thank you once again, Deb Gajic, for your insights on what students need to know about experiments in Psychology A-Level.
So
what